Good afternoon, everybody. My name is Edgar de los Santos, and I'm part of the technical support of Midas in the New York office. Today, I'm going to talk about SoilWorks, which is our 2D geotechnical engineering software. I'll give a brief introduction about the company, and then I'm gonna talk about the software and its key features, and then I'm gonna give a brief demonstration about the software, and so you can have a better feeling of how it looks and how the analysis is done. Midas is the number one in the engineering software market. Right now, it has distribution in more than 101 countries around the world, and we have around 450 employees around the entire world. We've been very successful in the distribution of licenses. We've distributed more than 30,000 licenses around the world. And so you can have a better feeling. This is the maps with the locations of the different offices. As you can see, we have our headquarters in Korea, and we have different branch offices around the world. We have one in India, China, Japan, and the one here in New York. These are some of the firms that we are in contact with constantly. We work with their projects because we offer consultants, and also we offer free technical support. So we are usually working constantly with these firms that are our users. These are the five main software that we develop here in the New York office that we distribute. As you can see, we have the Midas Gen, which is our building and general structures software. We also have the Midas Civil, which is our bridges and civil structures software. We also have the mechanical engineering software called Midas NFX, and we have two geotechnical engineering software. One is 3D, which is the Midas GTS, and the one that I'm gonna talk about today, which is Midas SolidWorks. So why SolidWorks? The software is very affordable. It is an all-in-one software. It includes 7 modules that you can work with, and it covers from ground analysis, slope, rock, soft ground, foundation, seepage, and also a dynamic analysis for seismic analysis. As you can see, the software is very extensive, intuitive, and reliable with the different results that can be obtained in the software. It has a pre and post solver completely integrated into each module. These are some of the mesh generations that can be created in the software. It is a finite element analysis software, so this is very important when we are trying to produce a model. As you can see, it is very powerful also. These are some of the analyses that can be performed in the software. As you can see, we have static nonlinear analysis, construction stage. Also, we have different dynamic analysis such as response spectrum and time history. We also have consolidation analysis and, for example, PY nonlinear analysis for the foundation module. We also have seepage analysis, and we have slope stability analysis, as you can see here. Now I'm gonna talk about each module, and I'm gonna develop a little bit more, but I'm going to emphasize on the slope and foundation module, which I'm gonna show later on in the demonstration. So starting from the ground module, this is used for stability checks in tunnel reinforcement. We can also analyze the lining in the tunnel that we are developing. For example, we can also check the stability of adjacent structures. And for example, here you can see we have different table results and graphical results that can be obtained from the software. All of our tables are compatible with Microsoft Excel. And as you can see, we can also obtain different graphical results from our analysis. We also have different design report generations from each module. This is an example of the tunnel module, in where the software generates a complete report with different views of the results, also different tables such as the soil properties and the materials used for the analysis. These are some of the graphical results. As you can see, you have multiple views of the analysis, which allows us to uh, have a better feeling of the behavior of the structure or the ground. This is one of the project applications, which is a mountain tunnel, in which we can perform a stress and deformation check in the software. Also, we can check the stability check and either consider or not the reinforcement in the tunnel. The second module that I'm going to talk about is the slope module, which is uh, basically done for slope stability analysis. We can do stability checks, and also we can have a couple analysis with slope and seepage. As you can see, we have multiple failure surfaces that can be assigned to the model. As you can see, we have a polygonal failure surface. Also, we have an arc surface, and we have a feature called auto search failure surface, in which the software, as it's called, auto searches automatically the failure surface of the project. We can perform multiple types of analysis, such as the LEM and SRM, limit equilibrium method, and strength reduction method. This is an example of the report that is generated by the software. Later on, I'm gonna show you in the demonstration how easy the software and how detailed the reports are. Also, we have different graphical results of the analysis. As you can see here, we can see the different factors of safety in the analysis performed. Just for example, if we click on the grid, we can see the different factor of safety on the grid. And also we can select one of the slides created by the software, and we can see a free body diagram of them, so we can have a better feeling, and the software indicates which slide we're taking a look at. Then we have the rock module, which is basically a slope stability analysis module, such as the slope module, but this is specifically for rocks. We have a database built in which we can define different properties of rocks, and also we have different types of analysis in it. As you can see, we have stereographic analysis, limited equilibrium, and retrospective analysis. In the loads, these are some of the loads that can be applied in this module. As you can see, we have multiple water pressure distributions that can be applied. Also, we can apply seismic loads, and we can also define external loads to apply to the different parts of the model. We also have stereographic analysis in the rock module. As you can see, we have different type of failures that we can define, such as plane, wedge, and toppling failures. The other module that we have is the soft ground module, which is used for primary and secondary consolidation analysis, and also for immediate settlements. As you can see here, these are the points of, or the locations for my analysis of the consolidation analysis. And these also we have the changing drainage properties that we can assign to different analysis case. We can also check, we can also have calculations of preloading height, and we can check the drainage functionality in the project. We can also have a couple analyses with 1D consolidation analysis and the slope analysis. We can also perform different parametric analysis. As you can see here, we can change the different spacings of the drain, so we can have a better feeling of how the behavior of the project is. We can also assign different preloading, and we can also obtain or perform 1D consolidation analysis. We can have stability check for adjacent structures also, and we can do construction stage analysis within the software. This is one of software applications for the soft ground module, in which we can, as I mentioned, calculate primary and secondary consolidation settlements, and we can also check and perform a finite element analysis. The foundation module, which is a very simple module also, it has a very intuitive modeling features. As you can see here, we can basically perform simultaneous analysis, switching or having different locations for piles and sizes or different areas, and all the different arrangements can be performed in only one model. You don't have to be running different modules and saving different files with different arrangements for the piles. You can do it in just one model and perform different analysis for the same model. These are the types of loads that can be applied in the foundation module. We have axial shear moment loads that can be easily assigned to each file, and then we can see the different behaviors of it. This is a design report generated by the software. I'm gonna show you later on in the presentation an example of how detailed the software is, or how detailed the reports are. This is a project application of the foundation module, in which you can see the group behavior in a set of arrangements that you created in the model. You can check the member forces, and that helps you to determine the different pile types, sizes, and shapes in order to have a better design. We also have the Seepage module, which can be used for seepage analysis and also flux analysis for tunnels, construction stages, and also we can couple it with the slope stability analysis. We also have pump design capacity for temporary structures and foundations. Some of the features of the Seepage module is that we can specify saturated and unsaturated grounds. We can have steady state and transient state analysis, and also we can consider the seepage forces. This is one of the application areas in which a dam with cut-off walls. We can check the optimal embedded depth of a sheet pile, and also we can do a stress seepage couple analysis. Also, the dynamic module, which is our last module, is mostly for seismic analysis. We can do calculations of maximum acceleration of ground layers, and also we can check soil structure interaction problems. We can easily perform our response or assign response spectrum loads to the model, and also time history functions. We have a database with different time history functions that can be selected in the software, and also you can import your own time history functions and apply to the model. The same thing for response spectrum. You can bring your tables with the different values, and these can be applied into the different projects. In the dynamic analysis, we have an application area in which we check the stabilities of structures under seismic conditions, and also we consider the dynamic nonlinear properties of the ground for this type of analysis. Another feature of SoilWorks is that it is very easy to use. It has modeling features based on CAD. As of now, us as engineers are very used to all the different commands and how to create different drawings in AutoCAD. and this helps us in SoilWorks because the software we can use the same commands that we use in AutoCAD for generating our model. We can also import different CAD formats into the software. I'm gonna show you later on how easy this is done. But basically, if we don't import them from CAD directly, we can basically create our own models. As you can see, we have copy, move, scale, rotate, mirror, and a lot of the commands that we already used to in AutoCAD. We also have different intuitive models for the different ground material properties, and you don't really need to have background knowledge in finite element analysis to use this software. We have various types of material of ground materials, and you can also define your own materials. If, for example, they're not in the database, you can import your different properties and assign them to the model. Some of the key features of the software is the fact that all the tables are compatible with Excel, and we can also obtain different graphical results. Also, we have something called Smart Surface, in which the software automatically generates different surfaces for closed domains. For example, if we have a very complex project, we don't have to start creating each surface for each part of the project. The software automatically creates a surface for each closed domain. That saves a lot of time in the modeling part of the project. We also have something called automatic smart mesh, in which we can create a mesh automatically just using the smart mesh feature. We can specify different refinements, as you can see here. I'm gonna show you later on in the demonstration how easily this is done, but it's basically selecting how finer or coarse the mesh is gonna be, and then basically the software will create a mesh for it. We have something called smart supports, in which the software creates or automatically assigns the different boundary conditions into the project. When we talk about all these smart features and we add them up, if we had to do those type of steps manually, these features would save us a lot of time in the modeling part. As you can see, why it's fast, easy, and affordable. It's fast, it saves time in the modeling, and also say it's time saving because it's so easy to use that in the learning time you don't have to really worry about. It has practical results, and the report generations are very detailed. It is very easy to use because any engineer can use it. We don't really need depth knowledge in finite element analysis or finite element method. And also we have it is very affordable because it's a 7-in-1 software. You don't have to be using multiple software to deal with your projects. You can use just this software, which it's 7 modules, and you can basically deal with any type of geotechnical engineering problem. Now I'm gonna go to the demonstration, in which I'm gonna show you a little bit how the software is. And if you have any questions, please feel free to type them in the chat dialog box. This is the graphical user interface of the software. As you can see, it has different buttons that uh, allows us to create the model and perform the different analysis. As you can see, we can go from left to right to generate our model and assign the different, for example, ground properties and different analysis cases and boundaries. It's basically done from left to right. The whole modeling and performing analysis can be done that way. As you can see here, also we have the listed all the properties that we have assigned to the model. In this case, I've already assigned ground properties just to save a little bit of time. But as you can see here, we have an extensive database with different soil properties that can be used. And also we have something called user defined, in which we can basically insert our own parameters for the soil properties and then assign them to the model. Right here I have listed different types of properties just to save a little bit of time, but this is how this part is done. Right now I'm going to import a CAD file so you can see how easily this is done. In this case, I'm going to perform a soil nail reinforced soil stability analysis, in which I have this CAD file that I already imported into the software. I also have defined structural properties, as you can see here. We have different element types for defining or the definition of structural properties. In this case, I defined nails for the analysis. And right now I'm going to basically assign the properties into the nails that I have here. I first select the nails, and then I can easily drag and drop the properties into the model. And that way those properties are assigned into these elements that I selected. After that, I can generate different surfaces. Just in case I want to edit, I can also use the geometry tab to edit my project. I'm gonna use the smart surface feature to generate the different surfaces of the model. Just by clicking the smart surface, you can see that all the surfaces in the model were created automatically. This saves a lot of time because sometimes we have to assign one by one soil layer property one by one, or defining the different surfaces one by one, for example. In this case, this was made automatically by the software. This will be easy because we already have, we only have 3 layers, but in the case that we have multiple layers, we can use a different this feature for the modeling. So after that, we can assign the different properties to the soil layers. If I, for example, select this property and assign it to, for example, select this layer and in order to assign this property, I just have to drag and drop the property into the model. See how easy this is done. So after the soil layers are assigned, we can then generate the mesh in order to perform the analysis. So for the mesh, we have the smart mesh feature, in which we can select the different refinements as I mentioned earlier, and then we can just with a click generate the mesh automatically in the program. So after that, we can then assign the different boundary conditions. If we go to the load and boundary tab and select the smart support, the software automatically generates the support for the entire project. As you can see here, the supports have been assigned into the project, and then I will create or assign the different properties for the LEM analysis. I have to assign them, but the good thing is that I can perform both analyses in the same file. After that, I can go to the analysis tab and define the different analysis cases. For example, here, as I mentioned earlier, these are some of the analysis methods that can be performed in the slope module. In this case, we just have to basically assign the different properties that we want to add to the analysis. We name it, and then from there we can assign different factor of safeties, for example. and then just add it to the different analysis cases. We can have multiple analysis cases in the same file, and that allows us to save a lot of time, and the amount of files is very reduced just to one file. Just for time saving, I have already a file in which I have performed the analysis, as you can see here. But from there, you can see that I performed three different types of analysis in the same file, and you can see the different factor of safety in each analysis. This is the arc failure surface generated by the program, in which I just had to define the grid range. And for example, here I can see the different factor of safeties that are obtained from this analysis. We also have the different slices in each factor of safety. And if, for example, I double click on one of the slices, I can easily select or see the free body diagram of the slice in the model. It has interactive views with the model itself. If, for example, I select and I go to the left, the program shows the different slices that I am verifying here. Also, you can obtain different stresses and, for example, displacements, as you can see here. We also have, for example, all this information can be generated into a report. In this case, I already have a file created by the software in which this is a sample report that was generated with the program. As you can see, first of all, it shows a table of contents, and then it shows the different applied safety factors that we generated. I manually selected the safety factor that the minimum safety factor that I wanted for this project. And then from there, these are the soil properties that I assigned to each layer. This is the material properties that I assigned for the nail. And these are some of the results that were generated by the program. As you can see, we have different views. The LEM, SRM, and SAM analysis. And we also have the different factor of safety and the check that the factor of safety is higher than the minimum that I established earlier. We also have different stresses. All these views and all these tables were generated by the software automatically, just by performing the report generation. Now I'm gonna go over the foundation module, which is this one, in which I have arranged two different types of foundations arrangements. As you can see here, this is the second arrangement that I made, and this is the first one. As you can see, we can obtain different types of curves from the different arrangements. I also have defined the different soil properties, as you can see here, to the different layers, and I've also defined the water level, as you can see here. After defining all these properties, I was able to perform the analysis. Also, I assigned the different loads, and the analysis is basically done the same way as the slope module. Here are the different modules, and we can basically jump from one module to another without any problems. This was just an overview of SoilWorks. If you have any questions, um, please feel free to contact us. And as you can see, our company is characterized by our technical support. We have a whole team dedicated to the software development for different software that you saw, and also we have engineering consulting in the office. For example, here we have 14 engineers that are here to provide you with services and also for technical support. We provide something called e-business, in which we arrange different sessions for, let's say, training or technical support, in which you can share your screen or we can share ours, and we can provide you with the different and answer your different questions and help you with your projects. We provide 24 hours of technical support free of charge. We also provide free training so that you can have and start your projects without any problems. And also we do individualized training, just in case there's a specific project that you want to work on. We can arrange a session and provide you with the different trainings. Thanks a lot for your help. If you have any questions, please feel free to contact me. My email is e.santos@midasuser.com. My name is Edgar de los Santos, and thanks again for participating.